A capacitor is an electronic component that stores electrical energy in an electric field. Unlike a battery, which can generally store much more electrical energy inside its chemicals, a capacitor stores less energy but can release its charge much faster. This makes capacitors very useful in electronic circuits where quick bursts of energy are needed. Inside every capacitor are two metal plates separated by an insulating material called a dielectric. These plates never touch, and that is very important. Because of this insulation, electric current cannot flow directly through the capacitor. Instead, energy is stored in the electric field that forms between the plates. You can think of a capacitor like a small bucket for electricity. You can fill it, and later, you can empty it again. To understand how a capacitor works, let's connect it to a battery. At first, current flows through the circuit. Electrons begin piling up on one of the capacitor's plates, while the other plate loses electrons. This separation of charge creates an electric field between the plates. As more and more charge builds up, the electric field becomes stronger, and it becomes harder for additional electrons to move. Because of this, the current gradually slows down and eventually stops completely. At that point, the capacitor is fully charged. Even though no current is flowing anymore, energy is still stored inside the capacitor. If the battery is removed and the capacitor is connected to a load, such as a resistor or an LED, the stored energy will be released. Electrons flow back through the circuit and the capacitor discharges. Capacitors can also be connected together in different ways. When capacitors are connected in series, the total capacitance becomes smaller, but the maximum voltage the combination can handle increases. This is useful in high-voltage applications. When capacitors are connected in parallel, the total capacitance increases while the voltage rating stays the same. This effectively increases the amount of energy that can be stored and is commonly used in power supply circuits. One important property of capacitors is that they block direct current, or DC, once they are fully charged, but they allow alternating current, or AC, to pass through. This is one of the main reasons capacitors are used so widely in electronics. Capacitors have many practical purposes. One of their most common uses is smoothing voltage in power supplies. Electrical power often contains small fluctuations or ripples, and capacitors help reduce these by storing energy when the voltage is high and releasing it when the voltage drops. Capacitors are also used for temporary energy storage, such as in camera flashes or motor start circuits, where energy needs to be released very quickly. In summary, a capacitor is a simple but extremely important component. It stores electrical energy in an electric field, charges and discharges quickly, helps control voltage, timing, and noise, and plays a key role in almost every electronic device.